Hello, and we're back talking about section 1.4. In this lesson, we'll be looking at the quadratic equation. There's actually 4 methods to solve a quadratic equation. Unlike the linear equations that we just finished with, in linear equations, we're basically just undoing what's done to the variable. We have a set of steps we follow for that. We're looking for our one solution. In quadratics, there's second degree equations, so we're looking for 2 solutions. Remember, the degree tells you how many solutions to look for. So again, we're on second degree equations, section 1.4 quadratics. So we have 4 methods: the zero factor property, square root property. We can complete the square to make it something that we can use the square root property on. And then there's the quadratic formula. Quadratic formula works for any quadratic equation regardless of whether it's factorable or not. So if we look at this example, this is a quadratic equation, x squared minus x minus 6 equals 0. It's second degree. It has a first degree in it as well, but you go by the biggest exponent, that's the degree of it, and that tells you it's quadratic. So this one will factor, and we're doing kind of the reverse of the FOIL method, x times x to get x squared, then the last times last has to be negative 6. So we could use a negative 3 and a positive 2. And I don't always know what those need to be just right off. Sometimes I have to think about that, try different numbers until I find something that works. But so just to kind of speed things up, sometimes it looks like I just knew it off the top of my head when I don't necessarily. I have to try and work this puzzle. So I'll do that in some of the demonstration, but always know that you know, I have to think about these a little while. It's not necessarily just this quick in real life. It's just for the video. I kind of usually move it along for you that way. But so this does work. If you FOIL it, first is x squared, outer is 2x, inner is minus 3x, and last times last is minus 6. When you combine your like terms, you get the right middle term, minus 1x, just as it should be. So anytime we're manipulating algebra, we should be able to show that the steps are equivalent. And here you can see that is equivalent. So this factored form works. So if you can get it to factor, it's called the zero factor property. It says if you have a quantity times a quantity, 2 things multiply to equal 0, the only way that can happen is if one of those has to be a 0. You know, 0 times anything equals 0. One of these or both of these has to be 0. So that allows us to set each factor equal to 0 and then solve each individual part, which basically will change the sign of that to positive 3 and the sign of this one to negative 2. Now notice, if I check these out, they both work. 3 squared minus 3, that would be 9 minus 3, 6 minus 6 is 0. It works. And then also negative 2 squared minus negative 2 for x minus 6. Check that out. 4, that'd be plus 2, and voila, that also works. So there's 2 valid solutions, and that's it, and that's all. There aren't any other solutions. We can have confidence quadratics have at most 2 solutions. All right, so other examples. I have one for you to try. 6x squared plus 7x minus 3. All right, so again, I always encourage you to pause the video, try that on your own to practice the active learning. But I'll go ahead with it. So to factor this by the factoring method, and again, not everything's factorable, but if they are factorable, this is one of the methods we can use. I would guess 3x times 2x. Now, I'm not sure if that's going to work. I'm really going through the process this time. The last times last needs to multiply to be negative 3. So maybe negative 3 times positive 1. Notice that gives me the first is correct, and the last is negative 3. That works, but I need to check. Again, we're FOILing. I need to check, do the O and the I part work? Inner is negative 6x, and outer is positive 3x. So no, I didn't get it right this time on the first guess. That's not the right middle term. Even though the first are right and the last is right, I didn't hit the right middle number. So I'm going to try moving these around in different ways and see what happens. Notice that the first still is 6x squared, and the last still multiplies to be negative 3. So let's check our inner and our outer this time. And you'll notice this time I got it. It's positive 7x. That's what it needs to be. This foils together to be the correct. There's just one way that works. The whole puzzle works out. Sort of like jigsaw puzzles, trying to get the pieces to all fit in place. So there we go. Once we get it factored, you can then set each part equal to 0. And then solve each part. Here we can throw the 1 across the line. Makes it positive 1. Divide by 3. There's one solution, 1/3. Over here, solving for x, we'll move this 3 across the line, divide by 2, negative 3/2. Now again, we can check those just like on the last example. Sometimes I'm better about that than others. I'm not as good about checking the fraction ones, but we could, and we can use our calculator, plug that in for the x's, make sure that works, plug that one in. They should both work if my algebra is correct. All right, next example. So we got one more to try. On your notes here, try number 4. Again, pause the video, check that out. So to work this, the first step is it has to be in standard form. I don't know if I've mentioned that, but in this video, but standard form means the quadratic equal to 0. You need the squared term, then the x term, the constant equals 0 before you use this method, or really any of the methods. So the 2 needs to be brought across the line, put in standard form. And then we proceed. Either for zero factor property, if it's factorable, or for the quadratic formula, both of those methods require it's in standard form to start those. So these are factorable. You know, our first method we're looking at, they're all factorable. What works here, let's see, 5x times 2x. If I do a minus 2 and a positive 1, FOIL that, it works. Set each part equal to 0. And then solving each part, you should have a solution of 2/5 and negative 1/2. Those are our two solutions, the solution set. All right, moving along. So that's the zero factor property. If it's factorable, you can always try that. If it's not factoring easily for you, we can always use the formula. So a lot of my students say they just prefer to go straight to the formula. So no, that's okay. That is okay. You do not have to use the factoring method. All right, but I want to go through all the methods anyway, so you're familiar with the options. So the next one we'll do is the square root property. So the square root property says, why go to all that trouble if you just have a constant, x squared equals a constant? You know, something squared equals a constant, we can simply square root both sides. So it's missing that middle term that makes the quadratics harder. So if you have this special case, as something squared equals a constant, you can solve it by just kind of like we did on linears, undo what's done to the variable. Undo that by square rooting the square. It brings it out as an x. You have to remember to say plus minus when you do this because we're looking for two answers. And would you agree there are two answers to this? What squared is 25? Well, 5 squared is 25, and also negative 5 squared is 25. So there are two valid solutions to that. And that's the technique. Anytime you take the square root, you're the one that brings the square root into the problem, you have to account for the plus and the minus situation. All right, let's look at some other examples of that. Okay, down the list, number 1, we have x squared equals negative 36. So here again, we can square root both sides, and that gives us x is plus and minus. The square root of negative 36 reduces to 6i. You might remember when you have the square root of a negative, that's the imaginary unit I. X squared equals 45. Square root both sides. So the situation this time is it's not perfect. Now we've seen this before in our earlier section. When it's not a perfect radical, we are expected to reduce it. So 45 contains the perfect square of 9. So we should reduce that by 9 times 5. Then take the square root of 9, which is 3. And don't forget your little plus minus. So those are our two solutions, positive and negative, 3 radical 5. Okay, number 3. if you had a quantity squared equals a constant, this process also works there. When you square root this quantity, the parentheses squared and then square root undoes that, brings out or releases the x plus 5. What you do to one side, do to the other side. Don't forget to say plus minus when you do so. Then we've got to reduce this. It's like the 45. And some of these you might start to remember. So certainly feel free to do that if you're starting to see some redundancy and you just now, okay, I remember that one. She said square root of 45 is 3 radical 5. Square root of 12 you might remember is 2 radical 3. Again, we break it down to square root of 4 times the square root of 3. The square root of 4 comes out as the 2. So you should reduce your radicals and then finish solving by putting the 5 across the line, and then that would be our final solution. Again, accounting for 2 solutions. They're irrational solutions because there's still a radical there. One more time, and again, I would encourage you to pause the video and try this on your own before I reveal the answer. Again, we can square root each side. The square and square root cancel out, bringing out the x minus 3 value. On this side, the square root of 50 will reduce to 5 radical 2. Again, 50 is 25 times 2. The square root of 25 is then released because it's perfect as a 5, leaving a 2 in. Oh, and don't forget, plus minus, right? And then bring the 3 across the line, making it positive 3 plus and minus 5 radical 2. All right, now, if it's not already something squared equals a constant, we can force it to be by completing the square. This is a forced method to make it this format. And you know, in algebra, we can do such things. We manipulate the algebra using our rules, and we can do things like that. So let me show you what that looks like. So the third method, say we have an equation like this example. It's not a candidate for factoring. Actually, it will not factor, and it's not set up for the square root property directly. I can't use this square root, because it has a loose middle term. So it wouldn't work in that form, but we have a method for that. On the next page, you'll see a list of steps to complete the square. So this works for any problems, always a method we can use. I don't necessarily recommend it though if there's fractions in it or a complicated problem. I'd probably go directly to the quadratic formula, the last method we've got here. But anyway, we do have to use this method in the next chapter to find the center of a circle, so it comes up again, so we like to go over it now so you are familiar with it. So the method is step 1. You have to have a 1 coefficient here. If so, go to step 2. Step 2, move the constant across the line. Step 3 is where the magic happens. You complete the square by taking half of the middle term and squaring it. Half of 6 is 3. 3 squared is 9. 9 is the number that completes the square. I add that to each side. Step 4 says that this is then guaranteed to always factor. It factors into the same things here. A binomial times itself, x minus 3 times x minus 3, or x minus 3 to the second. You can check that out, FOIL that, and see if so. It's equivalent. But we can trust this method. It's always going to be the square root of the x squared and the square root of the 9, so just bring down your square roots, and if it's minus, minus here. And then that makes it, like the problems we just did in the last rotation, square root property would work now. Now we can square root each side, releasing the x minus 3 and making a plus and minus of 21. Move that 3 across. 21 does not reduce, so then we're done with that. All right, we'll go over that some more in the next video, but I'll go ahead and pause there and see you in a minute.